All right, that's going. So fatigue and muscle cramps. So what's crazy about this video is watch this guy's calf after this play. So he's...
It looks so alien-like.
The game is being played in December in Waco, Texas. Temperature from this period was anywhere from 43 to 58 degrees. Seastrunk experiences a cramp during his run. We're all familiar with this episode and also understand how much or how such an occurrence can impact us all. As a strength and conditioning professional, we understand how this can be limiting to the athlete's performance. As trainers, we understand how a simple muscle cramp can lead to a cascade of events that ultimately leads to injury. And as medical staff, we understand how the methodologies in preventing against such an issue may have an importance to our profession.
You can see him start limping as he's running there as the cramp is hitting.
A famous quote by Bill Parcells. He says that half the games on any given Sunday in the NFL are determined by 7 points or less. And half of those games are determined by 3 or 4 points. As you can imagine, for such a small difference, every adjustment we can make to improve the performance of our athletes from beginning to the end of the game is of great importance. Baylor would go on to win this game with a score of 41-34. Unfortunately for Seastrunk, he was able to walk away without much of an issue. However, exercise-associated muscle cramps are present and a real issue. As you're watching this video, I want you to consider another story. Again, this is just an observation, but essential for some of the points that will be made from this presentation. That this athlete still drink as much as possible. I was still operating from the perspective of dehydration and electrolyte imbalance as the ultimate cause of exercise-associated muscle cramps. Don't blame my reaction as I sat there observing his calf muscle ballooning and then relaxing at almost a rhythmic pace. I went into my instincts and relied on previously understood information. Despite a great focus on nutrition and hydration by the team, by our training staff, and myself, I view greater hydration or more liquid intake as an opportunity to resolve the issue.
Wow,
more liquid,
like
more salt would resolve this issue. This was the line of thought for many games during that season. However, recent research has challenged this line of thought. Science and experience have forced me to review and challenge this typical.
All right, so that's the painful part of it. So have any of you guys ever had your muscles be sore after you're done working out? Okay, that's probably good. Have anybody ever had a leg cramp like we just saw? Oh man, I had a guy that I coached. He was probably 6'5". He was the first guy that I coached that dunked in a game. And that dude, every game in the fourth quarter for the first 4 games I coached him, would have a cramp in his legs. Every game. So we had to figure out, one, because he was 6'5", I didn't really take him out of the game because I thought he was in good enough shape to do so because he had been playing a bunch before he got to me. That was wrong. He had to take breaks because when I started giving him breaks, as much as he complained, at least he didn't get cramps in the fourth quarter. The second thing, he never drank water. The entire game. No wonder he had cramps every fourth quarter. Didn't matter if we were blowing them out or we were a close game or vice versa. Every game, he got a quart for those first 4 games. It was nuts. Did I forget something? This guy would get, so what we ended up doing with him was giving him, I would give him a giant water bottle at the beginning of the game, and like during warm-ups, I'd be like, drink, this is your warm-up. And then later, like at halftime, I would give him a Gatorade. I'm like, you must drink this or you do not go back in the game, is what I had to tell him. It worked. He drank it, and he didn't get cramps the rest of the season. But like, I had to, 1, give him some rest. 2, I had to make sure he was hydrated. So like, as the coach, I had to force him to do that. Have you guys ever been sore for days after you work out? So we'll talk a lot more about that. The bad part is the older you get, the more those long days after your workout that you will feel. Or like the other day, I reffed 12 games in 3 days, and it took me almost a week for my calves and my feet to stop hurting. And my wife was even looking at my feet as I was laying there playing video games one night. She comes walking in, looks at me and goes, your feet look like you just had ankle surgery again. I'm like, what? She's like, look at your toes. They're all like swollen. I'm like, holy cow, I'm getting swollen feet after reffing for, probably say 12 hours at least. I think it was 13 games. And I ended up getting paid almost $500 for that. That was nice. Long weekend, but after that check came in, I'm like, never mind, that was worth it. I don't know what it was per game, but it was worth it. So yeah, the older you get, I used to make fun of people when I was in college as a freshman on the basketball team. The seniors, and his guy's name was Aaron Perkypile. It's kind of the wackiest last name you'll ever hear, and there were 3 of them, like 3 cousins, all with that last name. And this dude would be like getting after practice. He's like, oh man, I'm so sore. I mean, I was 18 at the time. And I'm like, what? 20 minutes after practice is over, I could be back in there playing pickup ball. And I was, because I was actually the gym supervisor. My job was to watch people play sports or play and get paid for it. It was awesome. All I had to do was tell them, if you got hurt, go to the hospital and write it down and dust mop afterwards. Easiest job, best job in college. But I was ready to go do that every day. And these guys were like, oh, I'm so sore. And I laughed at them. Now I wish I could be 19 again and be able to recover in 20 minutes after a 2-hour basketball practice. So that soreness, the older you get, the more you're going to see that. And also if you have either clients or players, maybe even some parents that are going to come to you as a PE teacher, they're going to ask you, what can I do about this? I even had somebody the other day just asking me for stretches. I forgot what it was. They had something wrong with their leg, and they're like, you know any stretches for this? I'm like, are you asking me or not? They're like, tell me later. I'm like, okay. So I moved on. So we're going to go over some of the things that go into fatigue and its causes and those exercise-induced muscle cramps that we try to prevent our athletes from having or having ourselves. So first we're going to define fatigue. So fatigue is decrements in muscular performance with continued effort accompanied with sensations of tiredness. So this is before you get to the cramping stage. The inability to maintain the required output to continue muscular work at any given intensity. Pablo, have you ever had leg cramps when you're trying to climb a hill on a bike?
No, never.
Oh, lucky you. That's the one I've seen a little bit more. I watch a mountain biking couple that's they're pro mountain bikers, and hearing them have to stop in the middle of a race because their legs are cramping, and they're usually because they didn't eat during the race. To stay that way. But yeah, it can happen where you're not getting the amount of power that you want as a part of that. So it is usually reversible just by rest. You don't have to do much else when it's just fatigue. So the purpose of fatigue is your body saying, yo, something's wrong. You need to slow down and let me recover. That's what fatigue is, your body trying to tell you. So generally speaking, listen to your body when it says, ow. Also, so fatigue is a complex thing. They can't fully understand it because some of it's depends on what type of exercise you're doing, the intensity, depends on what muscle fiber types you have personally that could change whether it's working or not, whatever your training status and what you're eating. Whenever there is a basketball tournament and you're trying to go to the calf, I don't know if any of you guys went to any of these Adventist tournaments here. What's the one fruit you can't find in the calf? Yep. You can never find a banana because the players will eat them all. Do you know why? Bingo. Yeah, potassium, and we'll talk about that more here in a minute. So 4 major causes. You're going to have inadequate energy, delivery of your metabolism. Man, my mouse is just not. There we go. Now I can see it. Accumulation of any metabolic byproducts, lactic acid. Failure for the muscle to contract. Yeah, when it's not contracting, then there's problems. And then here's the one that they don't know completely yet is the altered neurological control of the muscle contraction. As in, you saw that video where the muscle is involuntarily going. That's a voluntary muscle. You're supposed to be able to think about making it go. And so when it's going involuntarily, there's some neurological connection either that's happening or not happening, and that's what they don't totally know. So yeah, they say they don't totally know exactly why. They can hypothesize and things seem to work, but it doesn't always work. And that's why they say it's not fully understood yet. So some causes of fatigue. Apologies. Energy, ATP production is not there. Any metabolic byproducts that are coming out of there. It could be neuromuscular things. It could even be the central nervous system. So those are all things that can cause all different types of fatigue. So when we start about some of the causes, we can start with our energy systems. So your PCR depletion coincides with that. So PCR is that the first, second, or third energy supply when you start going? Is it the first 15 seconds? Is it up to a minute? Or is it the long-term one? PCR. Is it first, second, or third? First. First one. So first is used for short, high turn. So when PCR gets depleted more quickly than the ATP, your body is going to be like, ooh, I'm getting a little sore. Just a little bit. And that's when it's switching over to the other systems. And you start breathing heavily. Your potassium ions accumulate, which may be a potential cause. So pacing helps defer the PCR depletion, so not sprinting crazily for too long. All right, some other ones there that could go in for this, for your ATP production. So your muscles will start to fatigue when your glycogen starts getting too low. You're going for really long times, 2 to 3 hours, marathon runners. How long did it take you to do the Anguin to Anguish thing? And that was what, 30K? Yeah. Didn't you run that?
Yeah.
How long did it take you?
2:49.
So there's the long-term performance there, just to give you an example of somebody who's done it. Your muscle glycogen, your liver glycogen, and this one's going to go out before the muscles do. So your glucose, bloodstream, and then to your muscles making that ATP. You could be hypoglycemic. Your brain relies on that, so that could be some of your central nervous system telling you it's time to slow down. Just muscle groups, fiber types, and then you rely more on the fat oxidation the longer you keep going, and that's why we talk about the 3 different substrates that we are getting our power from in ATP. So as your glycogen reserves are limited, they get depleted more quickly. Depletion is correlated with fatigue. So it relates to total glycogen, and then the rate of glycogen is unrelated. So like how it's total depletion, not just like how fast it goes down. But we do know that it's depleted more quickly the more intense your workout is. I mean, that's kind of just normal thought. I mean, the harder you work, the more you get fatigued. So, but this is why, is because your glycogen is not getting the ATP back to your muscles and everything. So your fiber type is another one that we're going to go through here. So your type 1 gets depleted after moderate endurance exercises. And the fibers recruited first will also be depleted the fastest. And so recruitment depends on the exercise intensity. Your type 1s are your light to moderate ones. Then you're going to start going into, after those go down, then you're going to your type 2s. And your type 2Xs are the last ones there. So kind of working through that. So depletion in different muscle groups. Activity-specific muscles are depleted the fastest. So if you're running, your leg muscles are going to go bad. They're also recruited the earliest and longest for whatever the given task is. So your depletion in your blood glucose, so your muscle glucose is insufficient for the exercise, so the liver starts throwing more glucose into the blood so that the muscles can get more. As the muscle glycogen goes down, the liver I sometimes can't pronounce things. As that one's going to go up because the liver's trying to add more to it. And then as your muscle glycogen depletes, then you become hypoglycemic and you start feeling the fatigue. So this is all happening pretty quickly. You're not thinking about it. This is just your body reacting, trying to keep that homeostasis of everything going on. So this would be your muscle glycogen as you start exercising. So it starts pretty high, and I'm assuming this was all by taking blood samples while somebody was exercising. Now, as they got to about the halfway point, 30 minutes, it dropped down. So you start at 170, 160, and it gets in half before an hour's up, and then goes even in half again in 2 hours approximately, and just keeps going down and down and down the longer you keep going. So Pablo, what did you do for that 2 hour and 45-minute run to keep your muscle glycogens up? Gels. Okay. That's all? You didn't have extra water or anything? They had like refreshing stuff?
Water in those goos.
So your glycogen came from the goos, but also you need hydration just to keep it keeping everything moving in there. Whoop. So your perceived exertion, and we'll do this on our test there too, where they give you a number, and you're say how hard do you feel you're going right now? As they get all the way, and this person ran, and probably this is when they just called the test. It was at the 3 hour mark. So you can see here so these would be all the different types of muscles here, or the fibers, and the fast twitch. Now the difference you can see in this fast twitch one is what color has it already started changing. So this would be also a fast twitch fiber. It's changing colors just a little bit. So that would be the start of fatigue. This happened in this muscle here. I think this was after a marathon runner finished a race, is what this one was from. My notes aren't popping up on me here, but pretty sure that's where this was from. So that would be all the muscle tears that have been happening, and it's starting to try to repair itself, but it's exhausted the fast twitch muscle, and so now it is kind of turning a little reddish brown, at least under a microscope. Same thing here. So fast twitch muscles are darker at the moment because there's more blood in those things they're trying to repair after it's been fatigued. So this one was interesting. How much glycogen is used in each muscle? So you have your calf muscles, you have your hamstring muscles, quads front there. As they were going level, that's how much they were using. As they're going uphill, how much more they were using. And then going downhill, use actually more going downhill than level on some of these here. Especially on your calves going downhill was a lot closer than going uphill than compared to level. All right, take a break, standing break. All right, so we talked about what causes fatigue. And a couple of times there we kind of had some throwaway things where like all the metabolic byproducts. So now here's the details of all the metabolic byproducts. That's what we're going to throw up here. So these would be, I believe those are phosphorus ions. So that happens when you take phosphocreatine and turn it into ATP. They lose that ion each time as it comes to make it or ADP is adenosine triphosphate adenosine biphosphate. When ADP ATP is that phosphorus ions going on and off and on and off. So that's one of the things you had. You'd have heat happening, and that's what your body retains. And then your core temperature goes up, and then you start sweating to try to cool yourself back down. And all that's just the byproducts there that we're going through. Lactic acid from your anaerobic glycolysis, trying to replenish all that glycogen in your body and in your bloodstream so that your muscles can use it to keep going. And then you also have some hydrogen accumulation which is causing the acidosis, so the acidity in which levels up the pH there. So your hydrogen accumulation, lactic acid, and then those two combined together. Short-term, high-term exercises, glycolysis, and then muscle fiber calcium. That's what that one is there. So lactic acid accumulates during brief and high-intensity things. Sometimes that can happen immediately, and other times it's going to take longer, depending on what kind of exercise and all those decents there. And that's what we're saying. The acidosis is the muscle pH going down. So there are some buffers to help the muscles not let the pH go too far down. So when it drops down to a certain level, if it goes a little ways, you just don't want to go too far. The cells can survive, but they don't function real well. And that's more ways your body's saying, slow down, slow down, slow down. So there's some actual numbers that people have gone and studied here. So exercise physiology actually has some really interesting studies. We don't have the things to do it here, to take blood samples and go through all those things, but it would be really fun to go to a big university that has all the stuff to do it. So if you want to do a grad program that studied exercise physiology, that would be really interesting to me. All right, so development of muscles are insufficient in major detriment to fatigues there. So we could also then reactivate oxygen for accumulation. So getting some more mitochondrial functions, slowing the rate of PCR recovery, and reducing the oxidative production there. So these are all things that we don't want to happen. So here's that muscle pH as somebody is sprinting. And so if they did a hard sprint, as they start to recover, it would start coming back up. And they kind of gave you the numbers here where you're trying to stay above. If it gets too low, then your glycogen isn't going to keep breaking down and you're going to fatigue really badly and start hurting yourself, tearing muscles and all those kinds of things. So that's why they have the number here, is you're trying to keep this above 6.4. So a person sprints, and this is how long it takes for them to get back up to where they were in the first place after one hard sprint. So I'd say call that like a 200-yard dash maybe. So a good 20-second hard sprint takes them 35 minutes for their muscles to completely recover their pH. I think of this, imagine Michael Phelps when he was racing how many races in the Olympics? I think his record was 7 or 8 gold medals. Is it 8 gold medals? And that's in 2 weeks. And every time, and some of those had prelim races. They had the medal rounds. Sometimes he was having to do multiple rounds to get to that point. So he was racing every 2 hours at times or less. So imagine how long, if it takes you 35 minutes for one hard sprint, trying to plot that all out to recover as best you can to get to that. Whew. He probably had his own exercise physiologist just helping him get through this. To plan it all out there. So the neural side, this is the one that we don't know as much about, but they're trying to come up with ways to study it. So failures may occur at the neuromuscular junction, which will then prevent muscle activation, and sometimes that might be involuntary, where your muscle just shuts down and doesn't work. But that's usually, I'd say that muscular junction is one that sends signals to open up the floodgates to allow calcium to go through and back and forth through those gates. So some things could include, and we don't know which all of them are, reducing the acetylcholine synthesis and release, alter breakdown at the synapse, increased in muscle fiber threshold, and you can train that a little bit, altering the resting membrane potential as well. So again, those are, we just don't know which all of these are or what causes fatigue. Whoop. So fatigue may also inhibit the calcium release at the sarcoplasmic reticulum. So this is the one that they don't really have good answers for. So the central nervous system plays a role in the fatigue. So that would be your spinal cord going up to your brain. We don't know all of it yet. So these are just some of these things that are conscious. So stress of exhaustive exercise may be too much. So sometimes we might think there's a mental block there at times. Person may be subconsciously or consciously unwilling to endure more pain, and there are definitely people I know that can handle a whole lot more pain than others. I had a girl, this was when I was in college, I think, and this parent of a church member, their daughter was playing in the Union College tournament, and it was on Saturday night. I was at the Vespers, and this parent came up to me and goes, should we let our daughter play in this game? I'm like, well, give me some details. Her ankle is black and blue. It's her senior year, Saturday night. They will probably lose this game because they're, the 8 seed playing the 1 seed. And they're like, do we let her play one more time? And I was like, man, I can't tell you exactly what to do because, you're the parents. But this girl's... It was swollen. She could barely put weight on it. I told them let her start the game. And then I told her coach, who's actually now a dean at Union. So I told her coach to just let him... I was like, I would start her, let her play a couple times down the court, and then pull her. That way she can say, I played in my last game, and basically do her curtain call early, like as a coach at the senior night, with 4 minutes to go in the game. And usually I would plan senior night to be a team I knew I was going to beat. So I put all my seniors back in with 4 minutes to go, and I would sub them out one at a time. So every stoppage from the 4 minute mark on, I would pull each one out and give them a big standing ovation. I would just do that person's curtain call a couple minutes into the game and then sit her down the rest of the night. Because you're going to lose against the number 1 seed. And probably you've already been blown out at this point. I would leave her in that long. It was that bad of a game that I think they were going to get killed. I don't remember what they did because I didn't actually go to the game. I think I was running score clock at a different gym. So I don't know exactly what happened. But that was what I told them to do. So discomfort of fatigue is a warning sign. So elite athletes can have a little better pacing and can tolerate the fatigue before they get to that point. There is some evidence that arousal methods can help achieve higher performance. It's perceived discomfort of fatigue. Those would be some interesting studies. I haven't actually looked them up yet. So if you want a really interesting thing for your journal on Thursday, that might be an interesting one to look up. Let's see. Psychological or psychobiological aspects also can be a part of this. I'm at 25 or 35, I can't tell. All right, so there's a conscious decisions to terminate activities. So there's an interaction between perceived effort and motivation. I've seen some self-talk strategies that people use. We're like, come on, Matt. I would yell at myself as I'm trying to get up the hill. Or maybe even what I use right now is my son likes to cheer me on as I'm trying to climb the hill as he's on the bike. Because he sits in front of me when I'm on a mountain bike. And he sits there and chants, go, daddy, go. Go, daddy, go. Anytime we go up a hill now. Which just makes me work harder than I probably should. So other fiber recruitment. So the stress of the exhaustion can be too much. Discomfort of fatigue is a warning sign, so don't ignore that. Again, elite athletes can do a little more than probably, and say they've trained their body to handle the fatigue rather than probably most of your clients or students, which probably don't. So most of the time you're going to tell them when fatigue happens, listen to your body. And say, unless you're like a trainer that's training elite athletes, then you might be able to go a little bit past that. So heat alters your metabolic rate, does all these things. Carbohydrates go up. You start losing your glycogen there. High muscle temperatures may impair function. So when you're exercising outside and it's hot, I was talking to somebody about Arizona the other day, and you try going for a hike when it's 100 degrees out in Arizona, and you're losing all that because you don't sweat there because it's gone like that. So you don't notice yourself dripping in sweat as if you're I just came from Mississippi a year ago. And when you walk outside, by the time I walked from my house to the school, I mean, I had drips of sweat when it was warm out, and it was only like 80 degrees. So your time to fatigue goes up the higher it gets. So they did find out, and they've studied this, the time to exhaustion is shortest at 11 degrees Celsius. I don't know what the conversion is there. Your time to exhaustion is shortest at 31. Interesting, though, muscle pre-cooling can prolong exercise. So does that mean you should be taking an ice bath right before a big run? No, don't do that. But not being too warm when you start might also be an advantage. Could be. Depends on what you're working on there. And there's kind of what that study looks like compared to the temperature. Time to exhaustion with temperature at 38 degrees Fahrenheit. Oh, here we go. 51 is the perfect temperature for exercising for at least your time to exhaustion. And 87 is the worst. And then here's also where the humidity is going to cause that change. 80% humidity. Woo. Ouch. Tolerable durations of high intensity exercises. Let's see. High metabolic rates can maintain oxidative metabolisms. So that increases with endurance and decreases with age. The older you get, the quicker you get exhausted, sadly. It can correlate with events anywhere from 2 minutes to 2 hours. So here would be the watts. I'm assuming this is biking. So power output right away would be pretty high. Wow, 700 watts on a bike, that's a lot. Above 300 is actually still pretty high. But see, it drops pretty quick before you kind of get to that spot where you fail. All right, another standing break. 15 slides to go. Who's singing Rocky? Is that you? Hey, Ethan, was there no place to turn in your lesson plan?
No, we couldn't do it on stuff like that. And then for some reason, David and we couldn't see him. So we were just like,
I thought I had made something that was assigned to just the four of you.
Okay, yeah, no, I can see it, but David couldn't. And then I couldn't turn it in on there, so we just had to do it.
Okay. I saw that when I got up this morning, I'm like, something didn't work. That's the first time I've tried assigning to just a group of people. So, all right. So after you get past the just general fatigue, then you start getting a little further to actual muscle soreness. So results from exhaustive or high intensity, especially the first time you do something. So like this would be if you tried a new lift in the weight room. The first time you do it, your chances of having muscle soreness after that is pretty high. So, but it could also be for any kind of exercise that you're trying for the first time. So it can be felt with acute soreness, which is right away. So that would be a drop of pH and those muscle pain receptors, and then edema, swelling. And then you could also then have some of that delayed onset soreness that somebody presented earlier about, which I call DOMS. So an upper body that could last for like a day. So like if you did, 3 sets of 25 push-ups, you might a day later be like, I can still kind of feel that. And I always feel it on the edges of my muscles. So like where it attaches right here, like if I do bench press or push-ups and I do a lot of them, I can feel it right there where it attaches to my shoulder, more so than like in the middle. My legs, on the other hand, I'll feel it right in the center of the muscle, like that whole quads or calves. And some of those, 2 days later, when I repped for all those games a couple weekends ago, my feet were feeling it, like different parts of my feet. like when I moved one toe, I'd be like, oh, or I'd start to get like a cramp in the arch of my foot just from like walking to class here the day after. So some of that onsets, those DOMs can be something small that can like really hurt in your foot, or it can be like your whole leg. So acute soreness, remember, what's the word acute mean? Short burst of movement. So acute, so those are some of those things from the first, all those terms that we had to learn that first chapter. So acute muscle soreness can be felt during or immediately, and it could be either sometimes strenuous, sometimes just a novel movement, running, jogging, something that you just think you should normally be able to do, walking a long distance maybe, or just going for like a Sabbath afternoon walk in the back 40. So you could be a tissue edema where things are getting swollen. I say my toes and my feet were all swelling up there. So that could happen right away and then go down. That's why your muscles after you, I don't know if guys probably do this more than girls, after you work out there and you do a bunch of bicep curls and you go look in the mirror and you pull this number and you start looking at it in the mirror and it looks bigger than it was the first time you did it, that's the edema. Not actually the muscles getting bigger because the muscle is a little bit swollen after a short. I'm not going to ask how many guys have done that because I'm pretty sure every one of them has. It could disappear. It could disappear in a couple of minutes, or it might take a couple of hours. The older you get, the longer it lasts. All right, so DOMS is the one that appears. Delayed onset muscle soreness can be 1 to 2 days after your exercise. It could just be from a like stiffness, or it could be like severe or even restrictive. I don't remember if I've told this story in this class, but when I took weight training in college, we did a day of negatives. And I don't know if I haven't done this in my class, but we actually did negatives on the squat machine. So, but we had like a leg press that you could press into. So you're like sitting down. So like you would purposely put more weight on it. And then your two spotters would take their hands away from the big plate. And then you would try to keep it from coming down. Well, as I walked into the dorm, the 11 steps to get into Prescott Hall, I tripped 3 times on the way up. Because my muscles were so sore that it was actually restricting the movement of my muscles just to try to climb the stairs. I ended up I started in the middle, I tripped, and I kind of moved a little closer to the handrail, and I tripped again, and on the third one, I'm like, all right, I was just like leaning on the rail because I couldn't walk up the stairs there after class. So some major, and my legs hurt for days after that one. So some major causes would be eccentric contraction. So your concentric would actually be going out. So like if I'm doing a leg press, as I press out, that's concentric. Eccentric is like when you try to slowly let the weight down. So those eccentric contractions are the ones that will actually cause more DOMs than another. So an example of that would be like when you're doing a level run compared to running down. It's going to be harder on your muscles running downhill because that's as you're trying to keep yourself from going too fast. That's an eccentric contraction, trying to keep yourself from going too quick. So that's not actually caused by the blood lactate. It's not actually what DOMS is. So some people kind of like, oh, I'm not getting the lactic acid out of my muscles. Lactic acid is gone fairly quickly. Your body recovers from that. So one that's not in your book, but we do have to kind of mention, is rhabdomyolysis. This is when it goes too far. So I just got to mention this one. As a physical educator, if you push a kid too far and they come and tell you that their urine is a different color, that means their muscles have been pushed too far, and it could be life-threatening because the kidneys are going to shut down. Doesn't happen often. Happened a lot more, 30 years ago before we knew that this could happen. So it doesn't happen often, but basically if you have a student or a client come to you and say, my urine is the wrong color after a workout, get them to a hospital. That's where that goes. Get him to an ER quickly because something could actually be wrong. So structural damage is indicated by the muscle with enzymes in the blood. So contractions of 2 to 10 of heavy training, the onset of DOM parallels the onset of those muscle enzymes in your blood. So the sarcomeres, the Z discs, are the anchoring points, and those are what transmit the muscle fibers to contract. That Z disc gets damaged after you do a lot of eccentric work. Got some pictures here coming so you can see what that actually looks like. So that muscle damage is actually what you kind of want to happen to a degree, because you want the muscle to break down and then rebuild stronger. It's like, but you just got to be careful. That's also that muscle breaking down that takes days to recover is what that DOMS is a part of. So inflammation and soreness are definitely connected. So those white blood cells are defending against foreign materials and pathogens. Those white blood cells count increases with soreness. So your body's trying to recover, trying to repair, trying to get any foreign objects or foreign things out so that it can repair itself. So those substances initiate the inflammation. So when you actually, your muscles look like they're bigger because you're checking yourself out in the mirror there, this is actually what's going on. So those damaged muscle cells are attached to neutrophils. Neutrophils release and attract chemicals and different radicals from the blood. And then those release other substances that stimulate the pain nerves to tell you, yo, this hurts. So macrophages are also a type of immune cell that help remove those different cellular things. Good old biology 101 lesson right there. All right, so here's kind of a very simplified version of this. This will be enough for, you can go a lot further than this, but this is enough for our class. So high tension in the muscles will then cause structural damage to the muscles and the cell membranes. The membrane damage, or its damage distributes calcium to homeostasis in the injured fiber, trying to get everything back to normal. And that inhibits cellular respiration. So that's also going to activate things that are going to degrade those Z discs in between. After a few hours, the circulating of the neutrophils, then that's going to produce macrophage activities, intercellular contents, and that's going to get a whole bunch of histamines, kinins, and potassium. It's going to tell those nerve endings it's okay, and it's going to get worse with those eccentric exercises. Fluid and electrolytes go into that area. Electrolytes are all those things that you get out of your Gatorades. That's one reason that they put it in there. Anybody know why it's called Gatorade? Huh? Do anyone know why it's called Gatorade? University of Florida is the ones that developed it. Gators. So that's why it's called Gatorade. And then somebody else bought it. It's not actually, under them anymore, but somebody that was studying there or was a professor there. That's why it's called Gatorade. All right, so here is what they were talking about, and let's stop here so we can see a little better here. So this would be somebody did a marathon, and they took a muscle, biopsy. Looks really painful, but you can see. So here are all the individual fibers, and then here's all the broken down parts. So all that stuff that we were just talking about that was going on, things are getting swollen, it hurts because it's being repaired. These are all the things that you're seeing in that. And you can even see there's more blood even in between here. So those are the individual fibers. If we zoom in even closer to those, you can see where there should have been like Z discs and I discs, Z discs, where it kind of zigzags back and forth as they start. These are just totally blown apart. So this would be before, and this would be after the race. So you can see how these are different colors now. There's parts that are just ripped apart. So that's actually like what a microscope of your muscle would look like after that. All right, so DOMS obviously reduces the amount of force you can generate, and this could be 2 days later. Losing strength, so anything in there is important. So ways to reduce DOMS. That's probably the one that everybody was going to ask you. My muscles hurt. How can I keep this from happening? So must reduce it for effective training. So 3 strategies. Start with low intensity and increase gradually. Minimize any eccentric work early in the session. Start with high intensity and exhaustive training. Soreness is intense at first, but much less later. So you could try to reduce it by training your muscles to not. So to say these are kind of backwards there. So these are 3 different methods. So you could try to train your body to do it, or you could try to reduce it just before it even happens. So a couple things not in the book. So massage, ice, heat, stretch, anti-inflammatories may help slow the recovery, and then antioxidants. Some of their protein carbohydrates within an hour also can seem to help there. Say those are just other ways of recovering. Muscle cramps. I got like a minute here and 3 slides. So we all know what that is. We saw that at the beginning. So treat it with stretching. So when somebody has a cramp, you go out there and stretch them. I had to do that for a soccer game the other day. So altered muscle control, neuromuscular control theory, there's probably a quiz question on that, is altered control of the motor neuron and the muscles. And it can get worse with age. If you have cramps already, like that player of mine had them every 4th quarter. That means we might have been worried about this. We're not going to listen to that. Any other ones here? Heat cramps is when it gets really bad. So that can be, usually dehydration is a part of that. That's where your sodium, ice, and massage is going to help a lot of those things. And we're done.